we're sorry for, I'm happy that we solved all these technical issues very hard. But something happens with these Macs when they connect to the HDMI here. They just get that won't work. So maybe you can start recording if you open the...
I started already.
Ah, you start already?
Yeah, and maybe you can be a bit closer than it's...
Okay. Okay. So I think not all people will find out, at least who were on the mailing list are here today. I hope that maybe they will be joining in the next session. But I'm really happy that we had like huge interest in the course, both from people who are interested in getting credits for their PhD studies and also for people who are just interested in topic in general. And so I really hope that the course will satisfy your curiosity about blockchains. So the plan for today will start with a brief kind of course introduction in which we talk about like some practical things, what to expect and the structure of the course, and also for people who are here for credits, what's needed to pass it. And a brief introduction of who we are and why we are offering the course. And then we'll start the first lecture with some basics that we will need to understand to get into, like, dwelling into what blockchains are and what they are not. Yeah. So I will be the one mostly giving the lectures. Maybe there will be one lecture at the very end that I keep it as a surprise. We'll see. Maybe we'll find someone, like some surprise person who will be giving it. So my name is Leila Bahri and I'm a postdoc at KTH, working under Sharonas Kirti-Jauskas, who's also the examiner for the course. Okay. So that's just like the name of the course. You already know it. That's the ID, and we'll be starting from today and most probably running until towards mid-March. I plan that this first half of the lectures will finish in the first week of March. We'll see this in one of the slides about the structure of the course. And then I also know from all people to whom I give presentations that I speak very fast. So if you think that I'm going very fast, just make the point and slow me down. So, what is it all about? In the registration, we asked about what do you expect. And I don't have here exactly what people have said, but most people have said that they just want to understand what blockchains are, maybe use them for research. But I had a couple of people saying that I want to know whether to invest in bitcoins and cryptocurrencies or not. So let's see if we can get that from our kind of encounter here. So the first thing that comes, I think, to the mind when we say blockchain is Bitcoin. And it's not any surprising because blockchain was born as a technology with Bitcoin. And so they are kind of intertwined, although as we will see through the course, we'll try to kind of separate them. Maybe we will not be able really to do it fully because we still need to understand some things about Bitcoin to understand blockchain. But our purpose actually is just like to separate them, pull them out, so that we just focus on what we get as lessons from Bitcoin and just try to apply it in our daily research. So why again then, when it comes Bitcoin, why Bitcoin got all this fame? There are so many other kind of coins, and as we will see in the second lecture, all this kind of movement for trying to find a cryptocurrency is not anything new. It actually has roots in the mid-80s. And I was myself shocked when I found like publications and even like initial software that yes, it didn't get more than like maybe a few people knowing about it, but now after Bitcoin, people started digging up all the old archives and starting things. We'll see also a bit about that. But what made Bitcoin like make all this buzz is actually its dollar value, right? So if we look at the charts, I don't know, can you see the slides clearly from where you are? They look from here a bit fuzzy. Okay. So this is kind of a plot of the price of Bitcoin, starting from just 2013, July to July 2018. And you can see that it has been almost like near $0. It's almost having no value, having like few cents, then about $1, shaking a little bit there. But the curve goes like very, very smooth until between 2016, 2017. And then there something happened. We don't know exactly what happened, and it's not one of the purposes of the course to understand here what happened. But something happened, and it made the price suddenly peak up to, here it says, to like $10,000s. It got even up to the markup of $20,000 per one single Bitcoin. And it's at that specific moment when people started getting interested in what is Bitcoin, and then Bitcoin works with something called blockchain, what is blockchain, and all of that. So yeah, so we are not here, this is kind of a quote by a baseball player, an American baseball player, Yogi Berra. He has this book in which he collects like set of kind of quotes, and he tries to give some life lessons, and he talks about all different topics, including investment. And so he says, buy a stock, if it goes up, then you sell it, and if it goes down, you don't buy it. I think you see already there's some twist, like because you start with buy and then don't buy. So we are not here actually to give any kind of advice on whether to buy or not to buy, to mine or not to mine. So it's not about Bitcoin. We'll be talking about Bitcoin, but it is not about this. Okay. So this is actually one of the nice things that I found. It's this Gartner technology hype cycle. It applies mostly to almost all technologies. So basically they start, I think I should be having some sticks since I don't have the pointer. Can you see it?
You have a pointer.
Yeah, okay.
You have the pointer.
I think it's the battery is over.
Oof.
Yeah, we didn't do our homework very well. Yeah. So this is like just, it goes like through time, and then the expectations out of a specific technology. So everything has a start, has a birth kind of date. So there is something that triggers the innovation. And mostly because we are mostly here working, we are researchers. So most of these innovations, they come out of the community in most cases. So it's someone who finds something, maybe that's not fully formalized, but then it's what triggers the following kind of innovation. So based on them, on their kind of framework, you can also look for it and go and read about all the details about how they explain it, but it starts like from something that triggers a specific innovation, and then everyone gets kind of interest in it, kind of on the spot. And so there is this peak of some inflated expectation when everyone starts talking about the technology as the technology changing the world, the one that will bring, like, I don't know, flipping app or allowing things that were never imaginable. And then, of course, like all the things that we start exaggerating about, we find that it's not up to that level of expectations. We are not going to start life in Mars with that technology. And so interest suddenly, like even drastically drops down. And they call this some threat of disillusionment. So then there are some people who still are hope into that the technology can provide something not maybe as up as it was expected by the general public, but it can still provide some value. And then these people try to do some work. These people are us, our community. So they start doing things, and then it goes a bit up until it plateaus within productivity. So how this fits within what we want to do? So the innovation trigger for Bitcoin, it has actually been Nakamoto's input, or the launching of Bitcoin in the market. This is what started all of it and all of the talk about blockchain and this new era. Peak of inflated expectations, it was exactly when the price of a Bitcoin in early 2017 hit this 20K markup, 20K US dollars. So this is when everyone started talking about blockchain. Oh, okay, thank you. Then it goes down. This is where Bitcoin is today. It's still not that much low. It still has some value, but not that much. And then it just went down so drastically again, and people started losing hope and saying that maybe even all the technology is not as much as has been promising. And what we want to do here actually, or our mission, is to restart kind of this tendency of making the technology better. Okay, so still, we didn't see what it is exactly about. So it's about, we said, Bitcoin and then blockchain. Okay. So as I said, until now, blockchain technology was born with and from Bitcoin, but it is an independent being in itself. If we have to consider it like it's an existing technology. This is what hopefully we'll be seeing here. It promises to revolutionize how modern society deals with trust. So it's true that we will not go up to all that high level of expectations on the technology that people were speculating about in all the forums. If you go just quickly and search about some posts about blockchain and Bitcoin. But still, it does hold some promises in there, and hopefully we will be able to discover them all together, and also to have, I'm looking forward more to the discussion that hopefully will be rising from the course. So basically what it does, it shifts the trust from one single trust entity to an open public. So that has been one of the main struggles for people from distributed computing or peer-to-peer communities, or who have some understanding about this. People have always been trained to decentralize things, to make services and to make all this like technologies run in a peer-to-peer fashion, but then there has always been problems. And we will see even now as things are developing and attack scenarios are developing and hackers are not as much as classical as they have been before and as on theory in paper, things have not been working that much. Of course, there is also another kind of factor, which is the business model, because centralized services, there is someone who gains from them, but when we go to decentralization, there is no one who controls whatever the output of the technology is. Well, we'll hopefully like discuss these things later. But the thing is that blockchain, at least if it brings something, it brings this promise that is still, or that is yet to be kind of proved, to shift trust from central organizations, like when we say we trust governments or we trust banks or insurance companies, etc., to a decentralized environment in which we don't have to trust the bank, like for example what Bitcoin has proved, or at least achieved. Okay, and I believe that the impact of blockchain will extend beyond cryptocurrencies, and that's why we are trying here to kind of deassociate it from Bitcoin. Some examples: identity management. So if you go to research papers, there are already people who have started talking about or designing solutions for identity management using blockchains. IoT security, since by definition IoT devices are decentralized, they need to communicate between them, they need to achieve some kind of common goals. Decentralized governance in general, and then something that is funny, unfortunately we kind of cut connection from the computer. I wanted to open the site, but you can later just open it. CryptoKitties. So there is this website in which they started like selling you some digital cats using blockchain technology. So basically you design a cat, if you are a cat lover, and then you buy it and it's yours and it's there in the blockchain and no one can copy it or steal it, and then you keep feeding it and giving it like some tokens and some. So yeah, people have been thinking about things like from real things to things as crazy as cryptographic cats. Okay, so yeah, we understood it so far. Even from the title, it is about blockchain, and I believe this is why you are here. So then what is blockchain? So maybe it doesn't make sense to start the course asking what is blockchain, but we need to have at least like some kind of common ground to start from. So do you have any ideas? What is blockchain? From whatever you have been hearing of so far. Anyone?
Distributed append-only database.
Distributed append-only database, yes? I'm not sure it's the first one that comes. Yeah. Distributed public ledger of transactions. Append-only is missing here. Okay. So it's, now when we say this, people who are from the distributed kind of computing community, and when they go and discover about what a blockchain is, they say it's not a distributed ledger. It's only a replicated ledger. Because actually we know that the distributed file is the one that we cut into different pieces, and different peers will hold like a different piece because the file is huge. But in a blockchain, actually, we do replicate it in full at the level of all the peers. And we will see that this is one of the basics for its security. So we cannot just have portions of it stored locally at the level of each peer. Okay, so these are all kind of valid to semi-valid definitions, ones that you would have heard of or even find on the internet. This is the definition from Wikipedia, which to my surprise, like Wikipedia has always been providing, maybe that's half of the past, now things are improving, it's providing more accurate things. So it says blockchain, originally separated blockchain, but now it became like that. is a growing list of records, which is again something that's an append only. And these records are called blocks, from which the blockchain, which are linked using cryptography. So these cryptographical links are what give the chain. And then each block contains a cryptographic hash of the previous block, a timestamp, and transaction data. Blah, blah, blah. And by design, blockchain is resistant to modification of the data. So I feel this kind of hits the note to some extent. And I want to share with you here a definition that I come up with from my understanding so far of what blockchains are or what they are not. And one of the expectations also from this course is maybe towards the end of the lectures, we all come up with a definition of what is blockchain, because it's not something fully formalized yet in the literature. So that's my tentative definition. Blockchain for me is a technology, so it's not only the ledger, which is composed of a set of techniques and mechanisms that are technical and managerial. Both of them, we will see that. There are incentives without which maybe this thing will not work, that enable secure management of a ledger or a database. So we still have this concept of a ledger. But it makes more sense when this ledger or this database is composed of some transactions that are temporarily connected, in which it makes sense to say that this happened before this. So we need some ordering of records through time in the database. And this technology allows us to do that in a pure public peer-to-peer fashion, offering a unified, agreed-on version, which is again consensus for people from distributed computing, of what has happened in the system. So we'll be coming back to that definition to some extent throughout all the course, and hopefully by the end we will just have the same kind of view and see to which extent we agree or not agree. Okay. Now what is blockchain, not as a definition, but what is its lineage? You remember when we saw this hype, this curve, this Gartner hype, we said everything starts with like some innovation trigger. So yes, blockchain came or was born with Bitcoin. Someone came and put the system, but did it just like come like that with some spaceship from something that is completely disconnected to whatever have been or used or has been constructed through time in all these research areas? Well, actually not. This is not the picture. It didn't come just like that from some external kind of. It came from the intersection of already one of the very well-established domains, peer-to-peer or distributed computing, with things I don't know to which extent people here will be maybe familiar. Who is from distributed computing peer-to-peer or have taken the course? Okay, so some people, but don't worry, because we start already from saying that the course doesn't need any prerequisites, so we're gonna be covering these. But it's related to topics like Byzantine agreements, which is basically the fact that we have different nodes in a completely peer-to-peer decentralized system in which there is no central manager, and we are trying to reach agreement on a specific value. And it has this term Byzantine from the fact that there is this analogy of all these commanders trying to take a decision of whether to make an attack or not make an attack, assuming that they can only communicate between them with some messengers, that also the messages can be delivered or not. We're going to see these details later. And things about consensus, we will see about safety. I'm sorry, this is not safely, it's safety and liveliness, etc. Another domain that also makes part of the lineage of blockchain is cryptography. So I think, or at least my guess, is that we have people here who have some background in distributed computing and peer-to-peer, but maybe not in cryptography. Am I wrong? Anyone here who has? Okay. Oh, okay. Quite good. So a bit less than the number of people here, but we still have some. So its basic things will not get into the depth of the mathematical formulations and all the theory of cryptography, but we will have to review the basics, like encryption, digital signatures, secure hash functions, because these make kind of the build-up of what a blockchain is. So not only my claim, but it's a fact actually, that blockchain is nothing but these two fields getting married and having a baby with some mutations in the way. Because we'll see that there are things that are very kind of familiar to people from this community. They will find that the same concepts exist in the blockchain domain, but that they don't really exactly match or fit, and they become kind of irritated. No, this is not distributed computing. And then the same thing for people from cryptography. So I see it as the child of combining these two research fields, but with some mutations on the way. Okay. So what happened? What's the mutation, or why these mutations have been needed, or why this marriage was needed actually? Because before all these mutations, I think this is one of the biggest issues in research in general, at least as far as my little experience has been concerned, and the experiences of people I've been encountering around me. I don't know to which extent you will agree. But we tend to just work on a specific topic, like you are in cloud computing, in edge computing, in IoT, in distributed computing, whatever. Yes, you have general knowledge about the other topics, but the communities are separate. Even conferences in which we publish are separate. And so you are not aware, maybe you are trying to solve the same problem from different perspectives, and if you just try to combine the two perspectives, you come at something better, which is exactly what happened when blockchain came. Okay, so in peer-to-peer or distributed computing, which I will call here 1.0, which means the traditional one that we've been, at least the ones of you here who are familiar with, the others will get to be familiar with, at least what we need for blockchains. The concern have been to deal with like some classical adversary. Now again, if we are in a perfect world, in a utopic world, in which we are like different peers that all follow a certain agreement or a protocol, then there is no problem, right? We can run whatever system. But life is not like that. There are problems. There are peers that will try to cheat. There are peers that will go offline, even if they don't try to cheat. There are some that like some problem will happen in the software that they are running, or maybe they will get attacked or hacked. And so traditionally in peer-to-peer, what people have been dealing with so far is what I call a classical adversary. That is quite nice. So we care, or people started caring in the community about timing. So synchrony, asynchrony, when the messages will be delivered. We are trained, for example, to vote, and we are only connected, let's say, by email in a one-to-one fashion. So how to make sure for whom we have voted. There is a timing issue, maybe someone or a majority of the votes who say yes, they are just like maybe delayed in the network, and so it's not that we have a majority of no, but the majority is saying yes, but their votes are being casted slowly. They have been dealing with crashes, so maybe someone is there and wants to cast a vote, but they just crash. The computer, like what happened with mine now, doesn't connect. Omissions, which means just like someone dropping some signals from the network. Byzantine, as we said, like it's kind of a summary of these things. And so considering all these issues that are also not easy issues to deal with, they are quite challenging, the problem was, okay, now solve the consensus problem in such a peer-to-peer system. And there are so many papers and there are many algorithms that try to approach and that also prove some impossibilities and possibilities. But now, what I claim is that we are in an era of a peer-to-peer 2.0, in which this adversary has now developed. So on top of being all of these things that we had in the classical adversary, we had to care about all these things of timing, crashing, and omissions. We are now in a much developed world, in which we don't have like this nice smiley devil. We are dealing with entities. If anyone here is Russian, this is not any offense to the opposite. It's like my hat down. And so meltdowns, for example. I don't know, anyone heard about it? Yes? So anyone want to tell about it? No? Okay.
It's a vulnerability based. It's a vulnerability that happens due to the speculative execution in the CPU, because when the CPU executes some code, it evaluates several branches at once and then throws away the ones that are not executed.
Yeah.
But so this attack exploits that vulnerability.
Exactly. So it's a vulnerability that's been discovered in most of the CPUs being constructed today, and it's also quite recent. It was unveiled in the beginning of last year, and yeah, I'm sorry.
It's bad.
Yeah, And what it results in, basically, it's a vulnerability that some people show that if you, it can be exploitable, and if you exploit it, basically a process will be able to read parts of memory that don't belong to it. And another one that is related to it is Spectre. It's also the same thing, almost the same story with a bit of differences in how, in terms of the vulnerability. And then reentrancy attacks. These are in smart contracts. We'll be talking about smart contracts in this, but there have been so many attacks on Ethereum and on all these blockchain technologies that are already out there. And all these 0 days that we are having every now and then, I think we should have all heard about 0 days, right? No? Okay, so this is a term actually known in security. It's like, you know, before people in the security domain, they were trying to have like this obscure security by obscurity, which means you close, you don't let people know what you have inside your system, and this is how you maintain your security. But then it has been shown, like in practice, that this is not the best way to do it, because hackers always find vulnerabilities. You cannot make something perfect. And so what then the approach would start to become security by transparency, which means that you unveil your architecture to some extent, like for example, with Intel making CPUs, and you let people, you give them these 0 days in which you say, okay, now try to attack me, try to find the vulnerabilities. So you would hear about them, for example, in the Java framework. Sometimes they say when they make a new patch or a new upgrade, we are on a 0 day, so all people who are in the security domain and can find vulnerabilities. So the only thing that I want to say here is that we are no more only to care. If we are to develop some peer-to-peer or a decentralized application, we are not only concerned about all these things that we have been talking about in the research community that I've shown in the previous slide, but there are more advanced and more modern things that we need to care about. Any questions? Okay. So given all these things, all these kind of security threats from hackers at the level of hardware and software, now the question or the problem becomes not only solve consensus, but let's run elections. Decentralized or centralized, it becomes more challenging. Or now make an e-cash system. So here it's not only that we want to take consensus about, let's say, I don't know, we take the course or we don't take, or we vote that we have class tomorrow or the next day. We are voting for things that have more incentives to cheat. Like an e-cash system, we are dealing with money. And so every peer would like to maybe take all the money in the system for themselves. Yeah, so again, going back to what is this about? Forget about cryptocurrency prices. We said this at the beginning. We are not talking about that. Blockchain, we will try to examine it like from a broad perspective. And then you can see it as, or all this course, as something that is slightly, take it with a pinch of salt. It's not going to be as formal as a course on distributed computing, but it's something like peer-to-peer 2.0, taking into consideration all the things that we've seen in the previous slide. Okay, class structure. I think you already know this information, but I just wanted that we are all again for people who are so busy to read emails or to read through the website or something. So we will be organized into 2 parts. The first part is a series of lectures. Tentatively, they will be these. The one that will start hopefully today, and it's the basics, the cryptographic basics, to be able to understand the blockchain. And then the second lecture, it will be a bit about history, that I thought that it's really interesting towards understanding blockchain, that it's not something that just happened between day and night. It has roots in the mid-80s when people started already thinking about that, and there were so many trials from scientists and researchers to develop some kind of e-cash or cryptocurrency system, but they have failed until Bitcoin appeared, so I think we need to go through that. The champion maybe of all of this, or at least what is in the records, is David Chom in 1983 with a very nice paper that I'll also be sharing with you. And I appreciate this guy because since the 80s, he started thinking about all these issues of centralization and the big brother in the middle, and started already anticipating for decentralization. So that will be our second lecture. It will be quite short. Then we'll get into the real stuff. So Bitcoin and Nakamoto consensus protocol, which is also proof of work. So we need to be able to understand that to understand blockchains. And then we're gonna get into more details about how things happen in Bitcoin or any other blockchain that is now into kind of development. We'll talk about transactions, this UTXOs, unspent transactions. We'll see this is a model of how to manage kind of money, and a bit of smart contracts. Then we have like a lecture on security and privacy in blockchain in general. And we'll talk about attacks, things that have already happened and how they have been kind of exploited, swaps, mixing, and lightning. These are like some of the things that we'll get into. And then alternatives and future directions from also research perspectives. And then a 7th lecture that will be extra. I'm trying to get someone like to talk about something fancy, so let's see. And then the second part, basically, so this is for like the building the understanding of blockchain. And the second one is for people who are interested into credits. So this will be like a couple of sessions more, or about 3 sessions, depending on the people who stick until the end. And they will be required, like, we will have some, just to pick up a topic of your choice and do some research about it, quick research, and come to participate, make a presentation or participate in panel hearing class. We can discuss about this later when time comes with the people who stay for mostly this event. Yeah, so how to pass the course. This is again only for people who are interested in credits. So we care about attendance, and I specifically make it into different parts. So you need to attend at least 75% of the lectures, because I believe this is important to make the last part, and then also the presentations. For presentation, you will need to prepare and disseminate a presentation about a chosen topic that is related to blockchain. It can be some reflections from your own research domain with whatever we will be seeing here in class. And then participate in discussions when others present, and then we need a written report. And you can be here very creative. It can be a visionary paper, a survey, a research proposal. You can maybe write a tutorial of how to explain blockchain and Bitcoin to dummies or to kids, or we'll see, we'll get into that. Okay. Expectations, whether you need credit or not, what to expect so that we are like on clear ground, and what the course expects from you. So hopefully we'll get a fundamental understanding of blockchains and its applications. So we'll mostly focus on the high-level theory. We'll get into some low-level technical details, but not a lot, not all through all the technical details, because I consider these as like more specialized for people who want to really delve into more into blockchains. An overview of existing research. There is not too much research around blockchains, but at least a few kind of main papers, we'll try to go through them, or a summary of them, and have some fun, hopefully. Okay, what the course expects. No special background or coding. So I don't know if people here have heard about, for example, Ethereum. So Bitcoin, for example, has its own scripting language. Ethereum has Solidity, its own kind of coding language. We will not get through that in this course. We will be talking about things like from a high-level perspective. But if anyone is interested in that, please let me know. And we may have like extra labs or homeworks for these people who are interested in that, but it's not part of the course itself. Yeah, some active participation in this. We consider it as a knowledge sharing experience. So I present what I know, and then if you already have heard things or have comments, especially for people who are like from the distributed computing and peer-to-peer community. Reflections on the presented content. I hope that we will have some nice discussions, especially under the light of everyone's own research. Yeah, and to create and join the fun, and then at the end come up with some definition to blockchain. Let's try to frame this, okay, and frame also our expectations on it. Yes, and again, I just want to make this one again clear once more. The objective is to understand blockchain and cryptocurrencies, because it was born from there, with the aim of exploring potential new research directions, hopefully. And it's definitely not an objective. It's not to understand Bitcoin and blockchain to better invest in cryptocurrencies or to mine. We will not see any of that. So who we are and why you need to be here to listen to me. So for people, because I think we had some few people from outside TTH, or like from Friesland or from main campus, maybe not everyone is here today. So as I said at the beginning, I'm a postdoc working under the supervision of Sharunas. He's also the examiner of the course, and he's here with us. And we are, he comes like from distributed systems, graph analytics, peer-to-peer, so he's like specialized in that. Myself, I had a bit of like tiny kind of expertise in security, privacy, and also some distributed systems, and we've seen that blockchain is just a combination of these two. This is how actually we came up to say, okay, let's start doing something about blockchain. Well, to my knowledge, if anyone here is informed about some other course, either in KTH or in Stockholm, about blockchain, please do let me or do let us know, because it will be really interesting to also reach out to these people and exchange ideas. So the topic, there are courses about blockchain in the US, but not much yet in Europe, a bit more in Germany, but not in Sweden. So if any one of you hears about any course or any academics who are working on something related to blockchain, it would be nice to get to talk to them. And yeah, we make part of this SCS department or division, and we are part of the Big Library School at KTH. Yeah. So, material for the course. This is the white paper. So who is here aware of this white paper? It's the one that is written by some anonymous identity. Yeah, okay. Have you read it?
Gone through.
Yeah, maybe just like scan it quickly, yeah. So basically no one goes back to read the paper. It's just a white paper, and it's the one that came up with a piece of software with a Bitcoin that was launched into the internet by this kind of mysterious entity, Satoshi Nakamoto, who could be a person or a group or who knows. We'll see that there is even a research. There are research papers trying to discover who Satoshi Nakamoto is. And they are trying to deploy some machine learning by going through papers from people in like things related to domains and trying to make train some models to see, based on the style of writing this document, who could be the author. And there are some people who really believe that they found whoever Satoshi Nakamoto is. And there are so many speculations about that, but we don't care about this in any case. So I recommend that we go back and read this paper. It doesn't have any technical details, but at least it puts back into kind of perspective why Bitcoin was thought of in the first place. And I'll also be taking some kind of excerpts from the paper. But the most thing that we'll base on is this book by Princeton. There are actually like few books about the topic, but we can say that they could serve for the purpose of a course. There is this one and another one called Understanding Blockchain. Understanding blockchain is mostly technical. It's more about coding and doing things with it. And so, as I said, we want to keep things at a higher level. And I found that this one is having a quite good coverage. And also the other nice thing about it is that there is freely available first draft of the book, which is almost similar to the final version that is being sold. I will share it with you. I will send it by email. I will just not put it on the website. So most of the material in some of the slides is based actually on this book. And it's an interesting book as well for extra reading. Okay. Yeah, we will be also discussing things about other interesting papers, and we'll be sharing these as time comes. I've been recommended by Amir actually. He talked about Slack. I was thinking that maybe we may need some platform if people are really interested into discussing and exchanging. And before going into creating like some kind of workspace within this, I want to know if there is interest in the class first. If people are used to Slack, how many of you here have used it before? Okay. So if you are, I mean, we can make a vote. If you are okay, we can just start it. I just don't want it to be a burden on you, that it's like some extra system that you need to go to and then receive. We'll be mostly communicating using the website and the email. But if you need like some platform for further exchanges or sharing of ideas, then we can do that. Yeah, so it depends on the synergies. When we will be meeting, I think this is one of the things that we need to fix. So I suggest Wednesdays, if it is okay for everyone here. And then I suggest that we either start like today at 2:15 with an effective start at 2:30. So which means we can be here from 2:15 and then we effectively start the lecture at 2:30 without taking a break, because it's going to be just an hour and a half. We finish at 4 or 10 minutes before 4. Or if you prefer taking a break, we go with the traditional 2 to 4. So who votes for the first one? We need to make consensus here. Okay. 1, 2, 3, 4, 5, 6, 7.
Is it possible to move it an hour early?
To 1, unfortunately not, because we booked the rooms at this time.
Uh,
Do you have something at this time from 2 to 4?
no, but then people from main campus can use the lunch hour to travel.
Okay. Okay. So you come from main campus?
Yeah, me
Okay.
too.
And was it difficult to make it here to be here at 2? I mean, for me, it's okay.
It was fine, because I tried
Hmm?
for Sigla.
So what's the best for you? Also to move it an hour ahead?
No, it's okay.
Okay. So you see, even without having any malicious intents, it's very difficult to reach consensus. So how do we do that? We do it by some doodle, or we just leave it and then...
now it's the rooms are booked for this slot.
Yeah.
So if there are no big oppositions, then I suggest we keep it. And in case there is something really important that for specific time slot, we can move it to another day or so. But I suggest that we keep these slots that are already pre-booked for Wednesdays 2 to 4.
So because I see that here we are maybe about less than 20 people right in the room, if I'm not mistaken. And on the list, we have 29. So it means that there are already like some 10 people who didn't make it. Maybe they are no more interested or something, or it could be also some issue with the timing. So I think
So
it's better.
Another option is to, if there is a revolt going on and then people
Yeah,
are
then we
upset,
can change.
then we can do doodle
Yeah,
and see if there are many people who are not.
Or maybe we could stick with it. Because this was announced quite some time before, right?
Yeah, and
Yeah.
others could have already made arrangements
Yeah,
for this
based on
course,
that.
so it
Yeah.
also wouldn't be nice from our side now to change the
Yeah.
rules. So again, unless there is something really
Mm.
for a big group of people that this does not work at all, I would rather suggest to keep it.
Yeah.
And then to change it in for specific,
as
you
we
know,
go.
if there is
Yeah.
some event going on and nobody can make it, and then we remove it.
okay. So let's say we keep it, and then if it's really a problem for someone, you email me, and then if I see that I have like more than 2 such emails, then we discuss it all together and we come up with a, okay? So do you prefer a start at 2:30 or at 2? Think about it and we come back to it in the last 5 minutes, okay? So that we don't stuck here. So basically this is a list of all Wednesdays from here until mid-March. So the one in green is today, and we are already here. We will have basically the same room 208. So let's meet next week at 2 or 2:30 based on what we decide at the end, in here, the same place. In this week, unfortunately, I won't be available, so we won't be meeting this week. And then again, the same room, except from the 27th. You don't need to remember all these things. I will be emailing the location like every week. And you will also have access to the slides, so it's just that you be informed.
And hopefully to the videos,
Yes,
if that
yeah.
will work
Yeah,
also.
Shadonas is recording everything, so you can also have access to the videos. But this doesn't mean that you don't come or that you sleep and then watch the video. Yeah.
But this is this is best effort attempt.
Yeah.
Microphones sometimes do not work or the batteries go dry, so
And the camera is focused only on me, so if there is some interesting discussion, I think that will be missed. So let's stay with this one.
yes, don't rely on it, but it might help for future reference.
Yeah. Okay. So any questions before starting the first lecture? Any? Concerns, issues? No? Okay. So let's go ahead and then start the first lecture. So some of the lectures are a bit long, which means that especially if there is discussion around, they may take more than a session. And some are short, so there could be like 2 during one session. I'll be also uploading everything on the website except from material that we cannot share open publicly. Then I will be emailing it, and if I email it, it means that please don't spread it outside of this group. Okay? So you can take a 2 minutes break before starting, and if someone wants some energy, here is dark chocolate and here is normal chocolate. Please pass it. Pass this one from here to this one. Okay. So we start in less than 5 minutes. 2 minutes. So just